Hey guys, Mr. T here doing another video. This one is on compound events and independent and dependent events as well. A compound event is one that's made up of multiple possible outcomes or multiple events. So if a coin was flipped and a six-sided dice was rolled, then flipping heads and rolling a 5 is a compound event because it's made up of the probability of flipping a heads and also the probability of rolling a 5. Whereas if I'm flipping a coin and rolling a six-sided dice and the event I care about is rolling a 6, then it's not a compound event because it's only made up of one thing, one event that I care about. Now, compound events can either be independent or dependent, and the way that you calculate them changes based on that. So you need to be aware of when the situation has independent events or dependent events. So events are independent when the two events, when the occurrence of one event doesn't have any effect on the occurrence of the other. So when one event happens, it doesn't change the probability of the second event occurring. So to calculate that, if you know that two events are independent, then the probability of the event A and B happening is going to be the probability of A happening times by the probability of B happening. So if I have an example here, if a coin is flipped and a six-sided dice rolled, what's the probability of flipping a head and rolling a 6, and flipping a tail and rolling a number less than 4? So how do I know this is independent? Because the two things that can happen are completely separate to each other. A coin is flipped, and whatever happens on the coin, whether it's heads, it's not going to determine what's going to happen on that six-sided dice. So that's how I determine that they're independent. So let's answer A first. What's the probability of flipping a head, and rolling a 6? That is going to be the probability of flipping a head times by the probability of a 6, which is the probability of a head is a half, 1 out of 2, times by the probability of rolling a 6, 1 out of 6. So 1 half times by 1/6, that's going to be 1 times 1, 1, over 2 times 6, 12. 1/12 is a probability, but I like making it a decimal and a percentage, so 1 divided by 12 is 0.083 recurring. So it's going to be 0.08 to 2 decimal points. It's around about 8% chance of you flipping a head and rolling a 6. Okay. B, flipping a tail and rolling a number less than 4. So flipping a tail and less than 4. So if I'm saying less than 4, that means I care about the numbers 3, 2, and 1. So that's the probability of tail times by the probability of less than 4. So that's going to be, what's the chance of flipping a tail? It's a half again, times by, what's the chance of rolling less than 4? Well, there's 3 numbers less than 4 on a six-sided dice. That's 3 numbers out of the 6. So that's going to be 1 half times by 1 half. 1 half times by 1 half is a quarter, which is the same as 0.25, which is the same as 25% chance of that occurring. So that's dealing with independent events, okay? Now let's deal with dependent events. So dependent events, looking at this now, I've just noticed that I've written does not. That is incorrect. Cross that out right now. And now I can talk about it. Dependent events are events where the occurrence of one event does affect the probability of the other events. So the way you calculate that is if A and B are dependent events, then the probability of A then B happening is equal to the probability of A, so same as before, but times by the probability of B after A has happened. So it's essentially the same the same formula as an independent event, but you are keeping in mind in your head that the probability of B may change depending on the situation. The probability of B may change depending on what's happened in A. And hopefully this example is going to show that. So a bag contains 4 blue counters and 3 yellow counters, 2 buttons, 2 counters are randomly selected from the bag without putting them back. Find the probability that both counters are yellow, and B, the first counter is yellow and the second counter is blue. So I know that this is dependent because I am not putting them back. I'm not putting the counters back, so that changes the number of counters in the bags, and therefore that changes the sample space on the second pick, and therefore that changes the probabilities. Okay, so that's what makes this dependent events. So both counters are yellow, so probability of both yellow. So what's the probability on the first pick that they're yellow? There's 3 yellow counters and there's 4 blue counters, so in total there's 7 counters. So the chance of picking a yellow first time is 3 out of 7, 3 over 7. Then I'm going to times it by the chance of picking out a second yellow counter. But remember, I'm not putting them back. So after I've picked out a yellow counter for the first pick, the 3 out of 7 chance, how many yellow counters are there? There's going to be 2 yellow counters, and because I picked a yellow counter and didn't put it back, how many counters are there in total? There's not 7 anymore, there's 6. So it's going to be 3 on 7 times by 2 on 6, that's going to be 6 on 42. So that's going to be 1 in 7 chance of that occurring, which is 0.14 to 2 decimal points, therefore 14% chance of getting a yellow first and a yellow second. B, that the first counter is yellow and the second is blue, so probability yellow, then blue. So, same as before, what's my chance of getting a yellow counter first? Well, 3 out of the 7 counters are yellow. But I'm timesing it now by, so the second is blue. After I picked a yellow out, how many blue counters do I have? I've still got 4, but how many counters are there? I picked out a yellow and I didn't put it back, so there's going to be 6 yellow counters. So 3 times by 4 is 12, on 7 times by 6 is 42. 12 is divisible by 6, 42 is divisible by 6, 7, so it's a 2 in 7 chance. 2 divided by 7 is 0.29 to 2 decimal points, therefore a 29% chance of that occurring. Okay, so that's an example of compound events, independent events, and dependent events, and calculating them. Apologies for the mistakes at the end here. I do them live. So yeah, hopefully that helps you out, and I'll see you in the next video.